Guys, this is our second video of solving trig equations using identities, so let's crack on. So, the identities again, remember, are these guys. We don't necessarily need to use them both. And this time, the equation we're solving is 5 cos squared of theta minus 9 sin theta is equal to 3 for values of theta between 0 and 360 degrees. So, how are we going to do this? Well, so there are no tans kicking around. Now, if we were to divide through by a cos to make the sine term into a tan term, then things are going to get messy, because on the right we're going to get 3 divided by cos. So we don't want that. So, we've got a cos squared term and a sine term. So we want to end up with an equation fully in terms of sine or fully in terms of cos. So we are going to change cos squared theta. So to do that, we're going to need the identity sine squared theta plus cos squared theta is equal to 1. So to get cos squared on its own, take away sine squared. So cos squared theta is 1 minus sine squared theta. So we're going to substitute that into the equation. So that's then going to give us 5 lots of 1 minus sine squared theta minus 9 sine theta, and that is still equal to 3. So now the equation is fully in terms of sine. We now want to expand and simplify, and what we're going to get is a quadratic in terms of sine theta. So if we expand the bracket, 5 minus 5 sine squared theta minus 9 sine theta is equal to 3. Move everything over to the right so that we've got a positive sine squared term. So if we do that, we can get 0 is equal to 5 sine squared theta plus 9 sine theta minus 2. So then of course we can write that as 5 sine squared theta plus 9 sine theta minus 2 is equal to 0. So there we have our quadratic. It's fully in terms of sine. Let's factorise and solve. So, bit of a tricky one to factorise maybe. One of our brackets is going to need a 5 sine theta. So then the other one is just going to have a sine theta. Now, we know the two numbers at the end have to multiply to minus 2. So that doesn't really give us many options. Our pair of numbers is going to be 2 and 1, and one of them is going to be negative. So, to get the plus 9 sine theta in the middle, we're going to have sine theta plus 2. Now that 2 multiplies 5 sine theta to give us 10 sine theta, and then if we stick a minus 1 in there, minus sine theta, or 10 sine theta minus sine theta, leaves us with positive 9 sine theta as we need it to. So this gives us our two solutions. So the guy on the right, sine of theta plus 2, tells us sine theta equals minus 2. But that gives us a bit of a problem. Sine can only be between 1 and minus 1. So there are no solutions to sine theta equals minus 2. So there's good news there. We can ignore that. So the left hand bracket, 5 sine theta minus 1. Remember what we're doing inside of each bracket, we're setting that equal to 0. And then in this case, we would solve for sine theta. So 5 sine theta minus 1 is equal to 0. 5 sine theta is equal to 1. So sine theta is equal to 1/5. So now we need to get our first value for theta by inversing sine. So theta is equal to the inverse sine of 1/5, which is equal to 11.5 degrees if we go to 1 decimal place. So that's one of them. Now to get the other, let's sketch the graph of sine of theta between 0 and 360. So it looks like that. We are finding the points where the graph cuts the line y equals 1/5. So we got this first one here at 11.5. So this one is going to be, remember this x-intercept is 180. So this second guy is going to be 180 minus 11.5, which will give us 168.5. So our two solutions for theta equals 11.5 and 168.5. Jobs are good, mission complete. Catch you later, guys.